Hello, welcome back to the continuation of differentiation. In this video, we are looking at how to differentiate a function of a function, which we normally call the composite function, and how to differentiate implicit functions. And with the composite function, we will apply a rule called chain rule. Chain rule helps us to differentiate all functions of function. Now, when we talk of a function or composite function, example of such functions can be this. Let's say we have f of x, which is equals to cos x squared, or we can think of another function like this, which also is called a function within a function or composite function. Another one can also be like this. A function of this sort, that is g of x is equals to square root of x plus 4, is a function of a function. I will explain that concept of function of a function to you very soon. So in general, we are saying that anytime you are given a question in the form this, y being equal to a function within a function, then we will employ chain rule. If I have a function, let's say y is equals to sine x squared. Now here we see that we have sine x as a function, or we can think of sine as a function, and we can also think of x squared as a function. And so we see x squared as a function, and we see a sine function. And so x squared is a function, and then the whole of this is also another function. And so we see this is a function of a function. Another example can be if I have y equals, let's say 2x plus 1 to the power 8. The whole of 2x plus 1 to the power 8 is a function. Then within the bracket we have another function called 2x plus 1. And so we see that this is a function within a function. And in such situation, it will be very difficult to expand the whole set before we simplify. Chain rule can help us to do this in a very simple way. So, suppose in general we have two functions. Let's say f of x and g of x. Then, if I compose the two functions as f of s into bracket g of x, then I can have another straight function. Remember that in composite function, this will be the same as saying f of g. That is f of g of x. That means g is inside f. Now, if you want to differentiate this particular function, which is y is equals to f of g of x, then we can say that we let u be equal to the interior function, which is the g of x. In that case, then we can write our f of our y to be equal to f of u. Okay. Now, if f of x and g of x are all differentiable, and we let u be equals to g of x, then I can differentiate u with respect to x, and I can differentiate y with respect to u. In that case, then the general form of differentiating y with respect to x will be equals to dy dx as dy du times du dx. It means to differentiate y as a composite function, it will be equal to differentiating y with respect to u here times differentiating u with respect to x. And this is what we refer to as chain rule. It means we are chaining the three functions. That is the function of y with respect to x, a function of u with respect to x, and a function of y with respect to u. This is what you call chain rule. Example will help you understand it better. Example 1. Differentiate with respect to x the function this. Now what I'll do is that I will let y be equal to the function, which is 4x minus 3 all to the power 10. Remember that this is a function to the power 10. I can use power rule if I can expand the whole of this power to the 10, and then I can use power rule to simplify and get my answer. But realize that if you want to expand this to the power 10 using the binomial expansion, it will be very tedious, and if you don't take care, the possibility of making errors is very high. And so chain rule can make this work very easy. And so what you have to do is, after knowing y to be equal to the function given, you can say let's say u be equal to the interior function, which is 4x minus 3. In that case, then we can write our y to be equal to, instead of writing 4x minus 3, we can say u to the power 10. Because we've already established that let this one be equal to u. And so we have these two functions here. We have a function of u with respect to x and a function of y with respect to u. Now, when I differentiate u with respect to x, that will give me 4. And if I differentiate y with respect to u, I'll have 10 u to the power 9 using the power rule. Okay, so if this is true, then let's see. Now, using the chain rule, to find dy dx, we say we will write dy du times du dx. Now we know dy du, which is this one, 10u to the power 9, and we know du dx, which is 4. And so when we substitute this into the formula, we have now dy du 10u to the power 9 times du dx is 4. And so I can write 40u to the power 9. But what is my u from the onset? Dy dx now will be equal to 40 into bracket. U is, we replace u as 4x minus 3, and then to the power 9 here, we put the power 9 at the top there. And so this will be the differential of the function given. What this means also is that if the function given to us, we initially had the function as 4x minus 3 to the power 10. What it means is that we can hold this as a function and differentiate it totally and say, if you differentiate 10 will multiply the whole function, which will give you 10 times to the power 9. Then we differentiate what is inside, which also give us 4. And so we can avoid the formula by just holding this as a unit entity, differentiate as with the power rule, that 10 will multiply this, and then when you finish, subtract 1 and get the power, then times, you differentiate inside and you multiply by it, and that will give you the answer as we have over here. Let's take another example and see. Example number 2. Find the derivative of this. Now, in a very simplified way, without using the formula, I will say that if I'm to simplify this, I'm going to use the power rule, which says that if I have s to the power, let's say 4, I'll just multiply this by this one, the coefficient here, which is 1, and I'm going to have 4x, then I subtract 1 and write 3. So that's what I'm going to do here. So I will say dy dx is equals to 7 times the whole function, which will be 7 into bracket 3x plus 7 to the power, then I subtract 1, 6. Then because there was another interior function, I will say times, then I will differentiate the internal function, which will give me 3. That means 3x power 1 is 3 plus 7 is 0. And so I get this. So I can simplify 7 times 3, which is 21. 3x plus 7, 6. This is the way of doing it without using the formula. I mean, that's the simplified way. But I want us to use the formula, become used to the formula, because we will need it in the near future. So going by the formula, we'll say we'll let u be equal to 3x plus 7. In that case, then the y can be written as, instead of 3x plus 7 to the power 7, it will be u to the power 7. So I'll differentiate this one with respect to u. So I'll have du dx, which will give me 3. That means if I differentiate this, I'll get 3 using the power rule. Then here will be dy du. Remember that y is in terms of u here. So it will be dy du, which is equal to 7u to the power 6. That's the power rule. And so using the formula, we say that dy dx, that's the general form of differentiating this, will be equal to dy du, and dy du is 7u to the power 6 times du dx, which is 3. So dy dx can be simplified as 3 times 7 is 21 into bracket u to the power 6. And what is our u? U was written as 3x plus 7 to the power 6, and that becomes the result. You see, we had the same answer as the first one. So that is the bottom line of the principle. The function given to you, again, I want you to understand the simplified way. The function given to us was y is equals to 3x plus 7 to the power 7. And to do this, we say dy dx will be equal to, we just assume this to be a whole function and say 7 times the function 3x plus 7 to the power 6 as we reduce it by 1, then times, then we differentiate what is inside, and that will give us 3. And so you multiply this by this, and that becomes your result. In fact, the power rule, like for example, if I have power rule of, let's say, 2x power 3, and I want to differentiate using the power rule. Power rule says that this times this is 6, then to the power 2. Then we differentiate the interior value, the x alone, which when you differentiate will give you 1. And that 1 times this will give you that. So you see that the power rule and the chain rule have something in common. They are the same. Just that when the power rule becomes more complicated, then we apply the chain rule, which works exactly as the power rule. So you see that there's no difference. Okay, so we have more questions to solve. Let's see. Example number 3. You can pause the video on this example, try your hand on it, and when you finish, you can check the solution I'm going to help you solve. Okay, now here we have y given us this, and we have to find dy dx. So we want to employ, you see, this is a very complicated function, because if you want to expand this function to the power 3 on 2 on 3, it will be more difficult to do using the power rule. And so if you don't understand the chain rule, some questions like this, in fact, you find yourself wanting. And so we'll first say let, again, u. In fact, for the u, you can use any other letter, but generally we accept u. So you see, most of the books use u. It doesn't mean you can't use any other letter. Okay, so let u be equal to the interior function, which is this one minus 4. And then in that case, rewriting your y, you are going to have y is equals to u to the power 2 on 3. So we differentiate first u with respect to x, and the result will be, this is 5. Okay, very cool. And then we differentiate y with respect to u, and it's a power rule we are going to apply. So everything here will multiply this to give you 2 on 3. Then then we subtract 1 from the exponent. So we have 2 on 3 less 1. 2 on 3 less 1. So that will be negative 1 on 3. Yeah, that is, you find the LCM of this one. This is what you get. Okay. So we rewrite the whole thing again. So finally, dy ds, which is the main work we want to find, is equals to dy du, that is 2 on 3 into bracket u to the power negative 1 on 3 times du dx, which is 5. And so when I simplify this 5 can multiply this as 10 on 3 times u, and u is 5x minus 4 to the power negative 1 on 3. So we can leave our answer this way, or better still, since we have exponent of negative 1 on 3, we can reciprocate it, and the answer will finally look like this. So I can say 10 over 3 into bracket 5x minus 4 to the power that. I believe you understand why it's so, because when this one reciprocates, it's more or less like saying 10 on 3 times 1 over then the function 5x minus 4 to the power on 3, and then so 10 times 1 will give you 10 here, and then the 3 times that will give you this. And so this will be the final answer of the differential of the question that is given. Example number 4. Now you can try your hand on this, check later with your solution. Now in doing this, here we have one, it's like we have a rational function here, which we can use what do you call it, quotient rule to solve this. But because of the exponent of 4 here, using the quotient rule will be a bit challenging, and so you can convert this and use it and use product rule, the chain rule to solve this question. And so what we can do is that you can rewrite the equation as 2x less 3 all to the power negative 4 by reciprocating. I mean, let the denominator go up and then the power becomes negative. So when that is done, then it will look like what we have already. If you let u be equal to 2x minus 3, then your y now becomes u to the power negative 4. And so you can go by the same process and then you get your answer as it's supposed to be. If you take your time, you realize that your result will finally give you dy dx as negative 8 on 2x minus 3 to the power 3. So this will be your final result. That means if you differentiate this one and you differentiate this one and you substitute that into the chain rule, this will be your final answer. Now example number 5. For this example, I would like to solve it with you since it involves two principles here. You see that this question has got 3x minus 1 to the power 3, and the power 3 means that you need to employ chain rule. And then at the same time, it's also a product function. I mean, there are two functions that are multiplying, and so we can also employ the product rule. So we are going to use product rule at the same time use the chain rule. Now before we solve this question, I normally enjoy myself with my students. When I'm teaching maths, I create a lot of jokes with mathematics, and I would like to create one joke so that we laugh and then we continue. A student was in the classroom sleeping while the teacher was teaching Pythagoras theorem. And this boy slept to the point that when the teacher was teaching, he didn't pay attention to any of them. Then after the teacher gave a work on the board, he drew a diagram this way, that's right angle triangle, and label ABC. And so let's say he put 4 here and put 3 here and put x here and ask the student to find x. So this boy was asleep, and when he wake up, he saw the question on the board. The teacher was using cane to cane those who are failing to answer the question. And because he was afraid, he didn't know what to do because he didn't understand what was going on. He was looking at the question critically, and he drew the same diagram, wrote everything exactly as the teacher has done on the board, and didn't know what to do. He said find x. So find x. So he was searching for s and he saw s here. So he circled s, brought an arrow down and say here is it. Here is it. And do we say it's right or wrong? Because he find s and he has seen s. So here is x. It's so funny, right? So here is it. I mean, he has seen x. And if you're to be a teacher, will you kill such a student for answering this question as such? The other instance also happened this way. This student is solving a question that said equation and almost getting to the final answer. He was to simplify actually, and he almost getting to the final answer. He was having 3 on 3 this way, okay, and instead of leaving the answer as such, he wanted to make it to the simplest form because it says simplify. He cancelled the 3 and wrote square root as the final answer. So do you think it's right or wrong? Well, that's your own judgment. The last joke that I want to take before we continue with the question that we are solving is this. This student was solving a question, and then at a point in time he came out with a statement like this: sine x. This was what he's left with, and he has to simplify to get a final answer. Didn't know what to do next. Actually, has struggled to get this. So he realized that, like algebra, you could cancel this n by n here. And after canceling, saw SIX. And he wrote the answer as 6 as the final answer for the teacher to mark. Because if you cancel n by n, 1 times SIS will give you SIX. And what is SIS? 6. So that is the answer. Oh, that is just by the way, just to keep you amused for a moment. Now let's get back to work. Let's get back to work. Okay, so here we want to use product rule first. Then the course of using the product rule, we will employ the chain rule. But the chain rule, we may choose not to use the formula, but use the simplified way that I gave you earlier. And so we know that product rule, we can let y, sorry, let u be equal to the first function, which is 3x minus 1 all to the power 3, and let v be the second function, which is x squared plus 2. Okay, so to find, first we have to find du dx, because you have du here. So du dx, we have u in terms of x, and now this is a chain rule. Okay, so I don't want us to say let u again be, so I want to just simplify this straight away. So the whole of this, this 3 will multiply the whole of this function, which will be 3 into bracket 3s minus 1, then minus 2 up there. Then we again multiply by the internal differential, which is 3s minus 1. When I differentiate it, power rule, I'll get 3 as a result. And so for the du ds, I can write 9 into bracket 3x minus 1 to the power 2. Then here for the v, I can say the ds, which is equals to, straight away I can use the power rule here and as 2x as the result. Right, so using the product rule, remember we are using the product rule because it's a product straight away here, just that we are employing the chain rule alongside. So by the product rule, dy dx is equals to u dv dx plus v du ds. I believe you remember this formula. And so this implies that when I substitute, I have u as okay, so 2x here plus, and then the v is given as s squared plus 5, okay, times du dv, I think this is the du dv, right? So that would be 9 into bracket, okay, so I think this is how the whole work is going to look like. And expanding at this side will be quite challenging, so what we can still see, so this can be written better still as this into bracket 3x minus 1 power 3 here plus I can say this would be 9, that's multiplying this one by this, which is very simple to do. So 9x squared plus 9 times 5, 45 here. Close that and then open this one as 3x minus 1 to the power 2. I think this is how the answer is going to look like for the differential of the function given. I think that's very cool. So these are some of the things you need to apply your knowledge on. You may have product rule and chain rule at the same time, or you may have a question that you need the quotient rule, the power rule, maybe at the same time the chain rule. Whichever way be the case, I mean, you should be able to do something anytime the question is given to you. Now let's see the next, or you can try this question on your own before we take the next subtopic. So you can try the following questions, example 6 and 7, do it on your own, and then you check your results. Now note that this one can easily be done by just knowing that it's going to give you 2x plus 5 to the power half, and you can use your power rule, the chain rule, to continue from there. Now we want to look at implicit function. Now we have two types of function here, the implicit and explicit. Mostly all the functions we've been dealing with are explicit functions. Now with the implicit function, we are saying that a function which does not express y explicitly in terms of x is called implicit function. Which means that if I give you a function like this, you see that this very function, you can't see y as a subject. And sometimes it's become more difficult to make y the subject of a particular function. Those type of functions are called explicit. So you see that the y and s are given the same form. I mean, they are all within the function. So you can see two or more variables, and none of them is the subject of the function. So if you have a function that you cannot see s or y as a subject, then that function is termed as implicit function. Another example is this. Here you can see y or x as the subject of the equation or the function. Then again, another function can also be this one too. This is more or less like equation of a circle. Okay, and you see that there's y is not a subject and s is not a subject. So these are examples of implicit function. And so such questions, they are also functions. So how do we differentiate them? Since y is not a subject like all the other functions that have been given to you, we say y equals y equals. And so here, when a question of this sort is given, how do we simplify it? So that is what we want to learn right now. We'll use example to explain how to differentiate implicit functions. And so for this very question, before we solve this question, I want to explain something to you very important, which will guide you to understand the implicit function. And that is this. Let's say I have y is equals to, let's say, 2x to the power 3. And I want to differentiate. Now watch out this. I'll differentiate y with respect to s, and I'll differentiate the 2s cubed with respect to x. And so when I differentiate y, I have y dy dx, okay, times, here is power 1. That 1 times this will give you 1. Y. When I subtract 1 from this, I'll get 0. And so y to the power 0 will give you 1. 1 times 1 is that. And the same thing will give you this. So it means that if you differentiate y, you end up getting dy dx. That is why anytime we see a function y and say differentiate, we say dy dx. Now when you come here to what it means is that if I multiply this by this, I have 6. Then x to the power 2. Also dx dx. It means I'm differentiating s with respect to x. And the ds is more or less like we cancel and we get 1. And so 1 times anything here will give you the same. That is why anytime we differentiate this, we don't attach the ds because it will still give you that. But when I differentiate this y with respect to s, I'll get dy ds, and that one, it is maintained. This is the basic idea that I want you to carry as you go through this one. Again, if I give you 2y to the power, let's say 3, and I want to differentiate this one, then what I'll do is that these 3 will multiply the 2 to give you 6. Then y, then we subtract 1 from this, which is 2, before we say dy dx, right? And so this one, we can't say this is 0, or we can't say this is 1. But if it's just y alone, power 1, the 1 will multiply this to give you 1y to the power 0, then dy dx. It makes sense. In that case, everything here becomes 1, and so we get dy dx. That is the basic idea that I want you to carry whilst you do the implicit function. So now, given 2x squared minus y to the power 4 equals 4x, this is implicit function because we don't see y as explicit in the form of having y is equals to. You see, so in differentiating, remember that this is the power rule we are going to apply because there's no product rule, there's no quotient rule here, and we don't have chain, right? So we are going to apply power rule, and the power rule, we normally differentiate term by term. And so term by term, we'll differentiate this one alone, which will give us 2 times 2 here, 4. You subtract 1, we get power 1. So we don't write the power 1. If you want, you can write it, but it doesn't make sense so much. Then here to this times that will give you 4y, then minus 3, then dy dx. Okay, because we are differentiating y, so it must be dy dx. Here too, this one should have been dx ds, but dx ds is the same as 1, so it doesn't come. But here for dy ds, it's not the same as 1, so it must appear. It's equals to, when you differentiate this one, you get 4. And here again, we can also say dx dx, but it doesn't make sense to write because to give you 1. So we just leave it as such. So this one doesn't come at all. So ideally, the whole answer becomes 4x, okay, minus 4y to the power 3 dy dx is equals to 4. But since we want to find dy dx, we are to find dy dx, we make this one the subject of the relation here. And so by so doing, we can now have our 4y to the power 3 dy dx is equals, we rearrange, so 4 minus 4x. So that means this one goes to join this to give us that. And dividing both sides by 4, negative 4y cubed, we have our dy dx is equals to 4 less 4x, all on negative 4y cubed. And you can see that 4 is a common factor here, so we can simplify this. If I factor the numerator, I have 4 into bracket 1 minus x, and the denominator will give me negative 4y power 3. And this can die with this. Okay, so finally, let me put the answer finally here. It's not right, but let me just do it. So dy dx is equals to negative into bracket 1 minus x, all divided by y to the power 3. So this is the final answer for this question given. Example number 2. Here we are given this function and we are to differentiate or find dy dx. So we take them step by step. First, we differentiate the first term, second term in order. When I differentiate the first term, it will give me 2y. That means the exponent times the coefficient to the power 1. Then I have my dy dx. Plus, then I come to the second term, 3x squared ds ds. I don't need to write that one. Minus 3y squared, then dy dx. Plus, when I differentiate the 6, it will give me 0. Remember, it's a constant. It's equals to 3y. And remember, if I differentiate 3y, I will get 3. Okay, because 3y is to the power 1. So 1 times 3 will give me 3y. Then 1 minus 1 is 0. So I'm going to have 3y to the power 0. And remember that 3y to the power 0 will give you 1. And 1 times this will give you that, 3. So I'm going to have this. But then I have my dy dx because I differentiated y. So I can rearrange this one in order to get what I want. And by rearranging, I'm grouping all the dy dx terms to one side. So I have 2y dy dx minus 3y squared dy dx minus 3 dy dx is equals to, and I have only this one left, which is negative 3x squared. Okay, so when I factor dy dx squared from this set, I have 2y less 3y squared minus 3, or dy dx. Can you see that? This will be left, if I factor this out, that out, I'll be left with 3y squared here and 3. So that's what I have. All is equals to negative 3x squared. And so dividing both sides by this, I have dy dx is equals to negative 3x squared, all divided by 2y minus 3y squared minus 3. So this will be the final answer. But then, watch out something. If somebody decide to group the like terms in terms of moving this and this to join this side of the equation, then that means that we are not going to get negative for this. This will be positive, and this will be positive, and this will be negative. And so the final answer, you realize that that answer will be this. Assuming that maybe you pause the video and you solve it on your own, the answer will be 3x squared, all divided by 3y squared minus 2y plus 3. So this will be another answer. So either this answer comes out or that comes out. I mean, they are the same. Okay. Now let's look at example number 3. Example number 3 is a little bit different from the first two examples we've solved. The reason is this particular part of the function, I mean this part, having x squared then y cubed. And here we see product rule here. So we are able to apply product rule in dealing with this aspect of the work. Okay, so this is what we do. So we are going to do step by step. So we see differentiate 3x squared minus x squared y cubed plus 4y is equals to 12. WRT means with respect to x. With respect to x. It's a mathematical symbol you can use to show with respect to x. At the point 2, -1. It means we want to differentiate at this very point. In that, which means is that what it means is that if I finish my whole differential, I can substitute these two values into the function to get the value. So let's see how this works. So I have, first off, I'm going to differentiate the first term, which will be that will be 6x. Okay, if I differentiate the first term, 6x, then the second term is product rule. So I can have this work to do. I mean, this is what I have. I want to write it somewhere here. I can hold this part and differentiate this part, then plus hold this part and differentiate that part. I mean, that is the product rule. Or I can use the formula. And since I don't want to use the formula within the sort of solving the question, I want to just go by that principle without using the formula work. And so here, I will just say hold x squared and differentiate y cubed, and that will be 3y squared dy dx, then plus, this time around, hold the y cube, and y cube is going to be negative because negative affect the 2, so y cube, and differentiate x squared, and that will give us 2x. Okay, so that is, so this part alone represents the whole of this part. Okay, then we come to plus 4y, so plus 4y. When I differentiate 4y, I'll get 4 dy dx. Everything is equal to 0 because when I differentiate 12, I'll get 0 because it's a constant. So that is the first part of the differential. Now we can now rearrange this to make it better. I would like to keep everything here to be positive because they are negative, so I want to keep them positive. Or let me simplify a little bit further before I do that. This will give me 3x squared y squared dy dx minus this and this together would be 2xy cubed, then plus 4 dy dx. Right. So remember it's equal to 0. Let me add that one. I want to keep the differential this side to be positive, so I'll move that one rather outside the bracket. So I have 6x, sorry for that, I have 6x is equals to 3x squared y squared dy dx plus 2xy. No, I think there's a slight mistake here. Sorry for this also. Here, this one has no dy dx, so I can keep that as minus 2xy cubed. Then is equals to, then I move this and this as 3x squared y squared dy dx plus, no, minus rather, okay. So this is what it's going to be, but I can still maintain this and this at this side and move this and this outside, which will still give me the same result. Okay, a little bit up to simplify this. So what will happen here? What will happen here? I can now say 6x minus 2xy cubed and factor this out, minus 4, then my dy dx. So finally, I will say dy dx by dividing both sides by this. Dy dx will be equals to, well, I can take 2x into bracket 3 minus y cubed, all divided by, because I'm trying to factor 3 out here, sorry, 2x out here, all divided by 3x squared y squared minus 4. So this is what I presume will be the answer for the question given. Sometimes I'm working alone, and when I make mistake, I may not see. So anytime you watch the video and you see probably skip of tongue or some error that is obvious, please do the correction for me. Remember, I'm a human being, I can easily make errors, but this is the approach. This is how we are supposed to handle it in the course of doing multiplication. Next question. Well, sorry, we shouldn't forget the fact that the question gave us y at a point 2, -1. It means we have to substitute that into the final answer before we generalize our result. And so if I put 2 in place of x and -1 in place of y, this will give me 2 into bracket 3 minus 1 to the power 3, all divides 3 into bracket 2 squared, then 1 also squared minus 4. And so I will get 4 times 2, which is 8, divided by, this will be 4 times 3, which is 12. 12 minus 4 also is 8. And so finally, dy dx, the value of dy dx is equals to 1. This is what we are supposed to get as our final answer, but not this, as I said earlier on, because they gave us the value of x and y, so we have to substitute that before we get our result. Example number 4, you can pause this video and try your hand on it. We are to find dy dx if this is equals to that, where p is a constant. P is a constant means that p can be any number. It can be 2, 3, any number at all. It means it's not a variable to differentiate. Or even if you differentiate the constant, you still get 0. Okay, so it's like you are having 2x or saying ps, they are the same because 2 is a constant, p2 is a constant. Okay. So now let's look at the solution. You can pause the video and try your hand on it first. If I differentiate the first term, it will give me 2x straight away, plus the second term will give me 2y, but then because it's y, it will be dy dx. This equals to, here I have two options, either to keep the 2p as something outside the bracket and have my xy like this, and now differentiate this and that. When I finish, I multiply through by 2p, or I can keep 2px as one entity and 2py as another entity. 2px and then at the same time 2py, and I will differentiate this, maintain this, then later differentiate this and maintain that. I mean, they'll be the same. So let me do it in a very simple way by keeping 2p out, then x. Now I maintain the x, I keep the x, then I differentiate y, will give me dy dx, and then plus, then I maintain the y and differentiate x, which will be 1. So I close my bracket there. Then I can now expand this by that and this. Okay, so let me repeat that part again. So I will expand this part, 2px dy dx plus 2py. Okay, so when I group the like terms, I have 2 dy dx minus 2px now this time around here we have 2py minus 2x. So this is what we have here. If I factor this out, I can have my 2y minus 2px, or outside the bracket we have dy dx. Okay, then here we have 2py minus that. So dy dx finally can be equal to 2py. I can factor 2 out here and keep y minus x, all divided by this. Here to I'll factor 2 out, and I have y minus px. So if I want to write my final answer in a more simplified way, I will say dy dx, these two die with this, leaving me with py minus s on y minus px. I mean, this would be your final answer. And once again, if there is any error, you pardon me and you correct it. But this is the approach, the procedure in which you're supposed to solve this question. Now, example number 5 is we have to show that this is equals to this if y is equals to 5 on this. Now, looking at this critically, realize that the whole of this equation looks like explicit function, where we have y is explicitly equal to 5 over 1 minus x squared all to the power 3. But if you look at the solution, that is, we have to show that this is equals to this. This has been left in implicit form, which means that this question should be solved in implicit way to get the answer in implicit form. And so even though this is explicit, you ought to convert it to implicit and solve using the implicit function. And moreover, we have another function here which the whole of this looks like chain rule, and so you are going to apply chain rule at the same time apply the implicit idea in solving this question. So what we do first is that we want to express this one in implicit form. Remember that this is over 1, so I can do cross multiplication and write y into bracket 1 minus s squared to the power 3 is equals to 5. And so when I write it this way, that means I've put it in implicit form. Okay, now you may ask a question like this. Can't we expand this by this? We can't do that. We can't expand this by this because of the power 3 here. And so you leave your distance like as it is. I mean, there's nothing you can do here. So we are going to solve implicit function here. Now, we can hold this and differentiate this, and later hold this and differentiate that. and here we have chain rule. So you're using the product rule at the same time chain rule here as well. So let's go. So when I hold y, then I differentiate this one, which will be into bracket, I have 3 times 1 minus x squared to the power 2 times interior function there, which is negative 2x. This is a little bit complicated. You have to be very careful here. Then plus. So just differentiating this one has given me the whole of this function here. Because differentiating this one alone means I'll multiply the 3 by the whole function, which gives me this. Then I subtract 1, then I power 2 here, times the interior function. That is using the chain rule. Okay. Then I go to plus. Now this time around, I'm going to maintain 1 minus x squared to the power 3 function and differentiate y alone, which will be dy dx, and everything here should be equal to 5, which is when I differentiate that I get 0. And so this is how my work is going to look like first. Now let's do a bit simplification. Remember that our target is to solve it to look like this. This should be our target. So we are solving the question, leaving our answer in the form of this. So that should be a guide to us. Now I can further simplify this. Note that this can multiply this to give me 6 negative, because I have negative here, negative 6xy. That is multiplying this by this 3 by that 2 will give me negative 6xy. Then into bracket 1 minus x to the power 2. Then on this side, I still have my plus 1 plus x squared all power 3 dy dx is equals to 0. And if you compare this to the answer, that is this one, you can see that we are almost through, just that the 6 here is positive and here is maintained like that. So if I look at my final answer, I can see that this 6 alright can be moved here alright. But before I do that, there's a common factor for this. No, without even looking at the common factor, we can rearrange this function. Let me have 1 plus x squared here. Oh, sorry, this should be minus, not plus. So that means this should be minus to the power 3 dy dx is equal to, that means I'm keeping this here, that's what I have here. Then I'm moving this one to the other side of the equation, which will be positive 6xy times 1 minus x squared to the power 2. And I want to keep this as a subject here, so I'll divide both sides by this one. And dividing both sides by that, it means I'm going to have 1 minus x squared all power 3 dy dx divided by 1 minus x squared to the power 2 is equals to 6xy. And you see that at the left hand side, this is having power 2, this is having power 3, and the bases are the same, 1 minus x squared, 1 minus x squared. So more or less one of these will cancel, or sorry, 2 of these will cancel one of the 2 of these, leaving out with 1. So it's like having a power 3 divided by a power 2. This will give you a. I mean, 2 of this will cancel 2 of this, leaving out with only a. And so this same thing I'm going to apply here. When I cancel, I'm going to have 1 minus x squared, then dy dx is equals to 6xy. So this will be the result. I mean, this is how the answer was put, and we have to solve it to leave our answer like this. Now, with example 6, I would like you to try your hand on this example on your own and see whether you get your answer to be correct. Here too, you have to show that this, when you simplify it, will be the same as that. So your aim is to simplify this. Go by the same way I showed you. First of all, multiply the y by this, which will be y. I'm giving you a clue, root of x cubed plus 1. And then this particular root will give you an exponent of half over here. That is when this one goes out. And then you go by the same approach. Then you simplify to get this as your result. So with this, we come to the end of video number 3 for the differential calculus. Watch out for the next video.